Well, we're going to get started. So obviously the AP exam is today. Several of you are taking it. Several of you are not, and that's okay. So first, if you are registered to take the AP exam and you did not complete the exam setup, which is the case for some of you, from what I've been told, you will not be able to test today. Now, that doesn't stop you from trying. You know, you can try and complete the exam setup right now, see if it'll allow you to, but from everything I've been told, if it wasn't done by yesterday, you can't do it today. Now, that may or may not be true. That's just what I've heard. So if you're registered for the exam and you want to take the exam, by all means, attempt to complete the exam setup right now and see if it allows you to. If it does, it's fine. You'll be able to check in later today at 12:30, 4 hours from now. Otherwise, you're going to have to request to reschedule the exam if you still want to take the exam. So there's that. Also, as far as exam setup goes, if you did not complete a practice exam for any of your AP classes within the testing application, you will have to complete the practice exam before it allows you to do the exam setup for the actual exam. If you've done that for at least one class, like if you have several AP classes, then you're good to go. All your exams will show up in your My Exam tab and you'll be able to access that. Otherwise, you have to do the practice exam. So again, if you are registered to take this exam and you have not completed the exam setup, I encourage you to try, see if it'll let you. Do the practice exam if you haven't. It's going to take about 30 minutes to just click through because it has mandated breaks in it that you can't skip. And see if it'll allow you to still register because we're 4 hours out from the exam. Otherwise, you're going to have to reschedule. So if that is the case for some of you, I apologize. It's just kind of how it is. So for those of you who are testing, I want to go review real quick over what the exam is going to be like today, give you some tips, and answer any questions that you might have. And we can do some review if that's something that you guys want to do, or I'll ask you guys a couple questions, see what we want to do at the end, because you may want to study on your own, so I want to give time for that. One other thing, grades, right? Some of you are fine with your grades in the class right now, and that's totally good. I've updated all the grades to reflect what your grade will be by the end of the day tomorrow when I have to finalize grades for this class, because the majority of you are seniors. If you're a junior, you get a little bit more time to complete stuff, but for seniors, I have to finalize grades by the end of the school day tomorrow. And that's when I have to submit senior grades. So I've updated grades as best as I can. Things that were submitted after school yesterday, I haven't graded yet. But everything else that has been submitted up throughout the school day yesterday, I graded during the day. So your grade should reflect whatever you did yesterday, unless it was turned in after school, then I'm going to grade it today. In Canvas, I have not synced the grades to Synergy yet. I'll do that tomorrow. And so that's why, even though the last multiple choice assessment was not due until tomorrow, it received a 0 as a placeholder grade so that you knew what your grade would be if you chose not to do it. Right? So everyone had the absolute best picture of what your grade is in the class. So if you're not passing this class right now, the best thing for you to do is to hit those multiple choice assessments. Get as many of them done as you can. Getting anything more than 0, which is what it's in there as if you haven't done it, will raise your grade. All right, how much it raises depends on how many points you get, but you give yourself a chance of passing the class by simply guessing on the entire thing. That's just the probability of the whole thing. If you get a few of them right, you'll get some points. That'll help your grade. Okay, so please, if you're not passing, do a few of those things. Attempt to move your grade up to a passing grade so you actually get credit for attending this class this year. Otherwise, it's as if you never showed up. Right? You won't get any points for doing this class. Right? And we want to get those credits. Right, so that's grades. Is there any questions about grades? Right. So now move on to the last little bit of review and expectations for the AP exam, for those of you who are taking it. All right. So here we go. Last bit of review. And in this, I'm not going to actually go over any problems or anything. We've done that. I don't want to overwhelm you today. So again, the exam is going to consist of 2 sections. Section 1 is our multiple choice. There's 40 questions. You get an hour and a half to complete those. Section 2 will have multiple choice and free response. There's 11 multiple choice questions. You get 25 minutes for those, and you have 4 free response questions. 3 of those will combine 1 to 2 skill categories. 1 will be the investigative task. It's like kind of like overarching with the theme of statistics and probability. And 1 hour and 5 minutes to complete those 4 questions. In total, the test takes about 3 hours of actual testing time, and then you add in your breaks and everything, and the 30 minutes before the test check-in. We're looking at about a 4-hour total commitment. About 12:30 to 4:30 is what you can schedule for. All right. So a couple things about what graders and readers are expecting on our free response questions. Right, first is that you understand what you need to demonstrate to the grader or reader. You're being graded on the correctness of your answers and your ability to communicate the methods you used to get them. Your answer is everything that you did to get the result, not just the final boxed value. Right, your job is to convince the grader that you understand the concepts covered in the questions. Right. If you only provide the numerical answer without evidence of understanding of how you got there, you will not get full points. Okay, so if there's just a bunch of math calculations on the page, but there's no reasoning, there's no stating, hey, this is the 1 sample t-test, right? That's what we're doing here. There's no frame of reference. There's a possibility you get no credit for that answer, even if you have the right numerical response. Right? If it's not attached to a context, if you're not giving some guideposts along the way of what you're doing, that's not going to work out. Be smart about your multi-part questions. Most of the free response questions will have multiple parts. Right? In the digital exam, you can move between the parts of a multi-part free response question. You can't move between questions once you submit your final response for the last part of a question and move on to the next question. You cannot go back, but within a question, read all the parts before you start answering them. They might be related and they might not, but they might give you hints as to strategies you might need to use. Use your own work, meaning if the final parts ask you to use the results from the previous parts, make sure you use your own results. Even if your results might be incorrect, using the results that you obtain to make proper inferences as far as if that were correct, right? This is the inference you should make. To that effect, use your own results. That demonstrates to the reader/grader that you understand the concept, even though you may have made a numerical error or a computation error. Right. Explain. If you are unable to complete one of the parts that is needed to answer the last part, make something up and explain what you would have done. Maybe you don't remember or don't know how to get the right numerical answer for something. You don't quite understand the question. And the next part is asking you to use that result from the previous part. Maybe you understand what that last part is asking you to do, and you can say, hey, if I had the solution here, this is what I would say. This is how I would interpret it. If you can provide that, you're still demonstrating that you understand the overall concept, and you're going to get some credit for that. Right? Answer the question you are asked. Don't write too much, essentially. Don't over-answer. Questions on the exam are worded very carefully and specifically. You need to carefully read the questions to make sure you understand what is being asked. Once you've answered the question, stop writing. Right? If you feel as though you've fully answered a question with one sentence, stop. There's no reason to continue. You do not need to fill the space provided to be correct. Right? Again, if you can answer the question completely with 1 or 2 sentences, beautiful, stop. There's no need to keep giving details. Always write your answers in context. Almost all AP Stats questions will have a real life context. Your answers must include the context. Again, just providing a number or just saying that we reject the null hypothesis or the confidence interval is between this value and this value. All right, and not saying what that means or how that impacts the context is incomplete. This is most important when defining symbols and variables and writing conclusions. Right? When you're making your original statement to say that, hey, we're going to be doing, finding a 99% confidence interval, right? Saying what the parameters are and what they mean in context, saying that we're going to find the 99% confidence interval for the true proportion of left-handed people at, the high school. That's now in context. Just saying you're going to find a 99% confidence interval is incomplete. When you're defining your symbols and variables, make sure you're using the proper ones or parameters or statistics. And say, okay, so P1 represents the true proportion of such and such, P2 represents the true proportion of such and such. We're going to find the difference, we have a hypothesis, right? You need to define those things within context. Don't just start using variables without telling the reader what they mean. Use vocabulary carefully. Terms like normal, independent, and sampling distribution have specific meanings. For example, don't say normal when you mean approximately normal. Right? We can say that things are approximately normal, right, if the sample size is sufficiently large, right? We don't say that it's normal because we don't have enough evidence to say that it is a truly normal distribution. We can say it's approximately normal. A standard normal curve can be used to approximate these proportions, right? So those are two separate things. Saying something is normal is different than saying approximately normal. Right? Don't mix up populations and samples in either words or symbols. Right? Remember, population parameters get like Greek letters for the most part, and then like capital letters or letters without any other notation with them. Right? We typically use P for a population proportion and P hat for a sample proportion. Right? We use mu, right, Greek letter mu, for a population mean, but X bar for the sample mean. Right? We use Greek letter sigma for standard deviation of a population. We use S or S sub X, S sub something for the standard deviation of a sample. All right? So make sure you're using the proper notation. If you get those mixed up, you're demonstrating to the reader that you don't understand the concept. So make sure you're using them appropriately. And if you don't remember, just write it out in words. Say sample proportion, sample mean. Don't use a variable, just say what it is. That's totally fair. All right. And those are the tips here for today. This is some quick tips for the free response questions. Just stop that. All right. So I don't know from you guys, those of you who are testing today, what you feel would be the best use of your time, up until the exam. Remember at 12:30 you need to start your check-in for the AP exam. You may want to tell your fourth period teacher, either you have to leave class early for the exam, or that you just might not, if you don't have to be in that class today, you might just tell them, hey, I have an AP exam today. Take the time you need for studying and preparation. That's up to you. You know what your situation is better than me. So keep that in mind. Exam starts at 1. Check-in starts at 12:30. Exam starts at 1. So you'll definitely miss your 6th period class. So keep that in mind as well. So I have a Kahoot that we can do that helps review some of the vocabulary and concepts a little bit. I could go over free response question that goes along with the scoring guide, so you can see one of those. Or, I can, end class early, so to say, and allow you guys to study on your own. What would you guys prefer? What preference do you have? I want to make sure you can prepare in the way that you see and think is best for you. Is there a preference? Or do you have any questions? Is there anything you'd specifically like to review? Or have a question or concern about having to do with the exam? I'm not getting a lot of responses. Okay, so if you would like to study on your own, please raise your hand. All right. If you would like to do the Kahoot review, please raise your hand. If you would like to review another free response question from a previous year's exam, raise your hand. All right. Okay. So based on the votes, we're going to go over the previous year's free response question going along with the scoring guide that I have prepared. Mostly because the people who voted for that are people who are taking the exam, as far as I can tell. All right. So we will go with that. Please, along the way, make sure to ask any questions or clarifying questions to help you understand what this is a little bit better if you need that. Otherwise, I'm just going to kind of run through this. I don't know why it's stuck there. There we go. All right, so this is review of the scoring guide. This is one of the questions from 2019 free response questions. I don't know if we did this one in class with you guys or not. I believe we didn't in this class period. No. All right, so we didn't see this one in class previously, so that's good. So this is question 4 from the 2019 released questions. We need to do with tumbleweed and being resistant to something. So tumbleweed, commonly found in the western U.S., is the dried structure of certain plants that are blown by the wind. Cochea, a type of plant that turns into tumbleweed at the end of the summer, is a problem for farmers because it takes nutrients away from soil that would otherwise go to more beneficial plants. Scientists are concerned that Cochea plants are becoming resistant to the most commonly used herbicide, glyphosate. In 2014, 19.7% of 61 randomly selected Cochea plants were resistant to glyphosate. In 2017, 38.5% of 52 randomly selected Cochea plants were resistant to glyphosate. Do the data provide convincing statistical evidence at the level of alpha equals 0.05 that there has been an increase in the proportion of all Cochea plants that are resistant to glyphosate? So this is the question. This particular question has no parts to it. It is just the answering this question. Do the data provide convincing statistical evidence at the level of alpha equals 0.05? When we see this alpha, that means significance test. I mean, we don't use an alpha for any other type of inference method. Right. So when you go into the scoring guide, the very first thing that we see is the intent of the question. When the people at College Board and AP wrote this question, what was their goal? What did they want the student to demonstrate? Right. The primary goals of this question were to assess a student's ability to perform an appropriate hypothesis test to address a particular question. That's the overall goal. Right. More specific goals were to assess students' ability to state appropriate hypotheses, identify the appropriate statistical test procedure, check appropriate assumptions, conditions for inference, calculate a correct test statistic and p-value, draw a correct conclusion with justification in the context of the study. Right. So specifically, there's the primary goal, perform a hypothesis test. Right. And then we have 5 tasks that shows that we know how to perform a hypothesis test. If you do the 4-step process, state, plan, do, conclude, you will cover all 5 of these things for a hypothesis test. Same thing for a confidence interval and so on. For any type of inference, you should do that 4-step process. It covers all the parts. All right. For the solution, the scoring guide breaks down the solution into 3 parts. All right. There's the setup, just say essentially the statement and part of the planning step as far as our 4-step process. Doing the math, and they're doing the math, it's the other second part of the planning step along with the do step in our 4-step process. And then section 3 is the conclusion, conclusion step. Right, and the setup, there's defining of parameters based on the context, stating appropriate hypotheses, stating the appropriate significance test, and the accompanying formulas using the defined parameters and statistics. Section 2 is checking the necessary conditions. Right, so this part and this part is the planning step of our 4-step process. Doing calculations, finding the p-value, show and explain your work. It's the do step, and conclude. State your conclusion based on your work. This must include the original context. So for the solution, this is a example solution from the scoring guide. They start with their essentially statement. Right, but first what they do is they define variables before making their statement of what they're going to do, because it allows them to use their variables in their statement. So they let P14 represent the proportion of the population of Cochea plants in the western US that were resistant to glyphosate in 2014. It's very specific. We're defining the parameter P14 and telling the reader what it means in the context of the original question. Let P17 represent the proportion of the population of Cochea plants in the western US that were resistant to glyphosate in 2017. Basically the same statement, just switching out 14 with 17. Right, and now we've defined our parameters. And it's the appropriate parameter. We're talking about proportions, so we're using P. The null hypothesis, H sub 0, such that P17 minus P14 equals 0, is to be tested against the alternative hypothesis, H sub A, such that P17 minus P14 is greater than 0. Right, we have a specific direction for our alternative hypothesis. based on the fact that we believe P17 is greater than P14. Or at least that's what we're like trying to find evidence for. An appropriate inference procedure is a two-sample z-test for a difference in proportions. The two-sample z-test, right, is the inference method. The formula for the test statistic, so they're going even further and providing the formula using the parameters from the context, right? So z equals p hat 17 minus p hat 14 divided by the square root of p hat c times 1 minus p hat c divided by n17 plus p hat c times 1 minus p hat c over n14, right? Remember, n17 and n14 is the sample sizes from those 2 years. P hat c is the pooled estimate of the proportion of resistant plants for 2014 and 2017 combined. Whenever the null hypothesis is that there is no difference, right, that P17 minus P14 is 0 for this case, you must use the pooled estimate, right, P hat C, which is the number of successes in 2014 plus the number of successes in 2017 divided by the total sample size between the 2 years. That is used to determine the standard error instead of the actual sample proportions. So this will typically be the case for any two-sample z-test, because for the most part, you're going to have a null hypothesis that says there is no difference. Next, they go into checking conditions, right? We've done the statement. We did the first part of the planning step, right? We said what inference method we're going to use and provided the formulas we're going to use. The next part of the planning step is checking conditions. All right, the first condition for applying the test is that the data are gathered from independent random samples from the populations of Cochea plants in the western US in 2014 and 2017. The question indicates that a random sample of 61 plants was taken in 2014 and a second random sample of 52 plants was taken in 2017. It is reasonable to assume that the 2017 sample of plants was in no way influenced by the 2014 sample of plants. So this first paragraph is giving evidence that the randomness condition has been met. And we have independent random samples. Right. The second condition is that the sampling distribution of the test statistic is approximately normal. Right. We refer to this when dealing with proportions as the large counts condition. That is what we use to show that the distribution is approximately normal. Right. This condition is satisfied because the expected counts under the null hypothesis are all greater than 10. The pooled estimate of the proportion of resistant plants is p hat c equals about 0.2835. The estimates of the expected counts are 61 times 0.2835 is 17.29. All right, 61 times the proportion of failures, 43.71, 14.74, 37.26, all of which are greater than 10. Right, so not only do they say like, hey, to show this is approximately normal, we need to show that the expected counts are all no greater than 10 if the null hypothesis is true. We use that pooled estimate for the proportion to check this, right, and we get all those counts are greater than 10, and the condition has been met. Because the sampling must have been done without replacement, the independence condition, which we refer to as our 10% condition, right, for each sample should be checked. Information on the population sizes of Cochea plants is not given for either 2014 or 17, but it is reasonable to assume that each population has millions of plants. Therefore, it is reasonable to assume that the sample sizes are less than 10% of the respective populations. Right. And again, typically, if you're not provided the actual population size, you can make a statement similar to that, saying like, hey, it's fair to assume that the population size is fairly large and that, you know, the sample sizes are less than 10% of the respective populations. So we have our random, large counts, and 10% conditions being met. We move on to the calculation phase, the do step. Right? Using the pooled estimate of the proportion of resistant plants, p hat c equals approximately 0.2835. The value of the test statistic is z equals, well, this mess, approximately 2.21. Now remember, the direction of our alternative hypothesis is greater than. So we want to find the probability that z is greater than 2.21. Right? If we look up 2.21 on table A, it will give us a fairly large proportion, right? About 0.9865. All right. That's because looking this 2.21 up on table A gives us the probability of z being less than or equal to 2.21. We don't want that direction, we want greater than. So we can either find the less than proportion, the 0.89865, and subtract that from 1 to get this p-value, or we can simply look up the negative 2.21, and it will give us the p-value of 0.0135. Alternatively, you could use your calculator and use the normal CDF and have the lower bound be 2.21, the upper bound be some crazy large number with the mean of 0, standard deviation of 1 because we've normalized this value, and have your calculator calculate that, and you'll get something approximately 0.0135. All right, those are the options. Because the p-value is less than alpha equaling 0.05, there is convincing statistical evidence to conclude that the proportion of resistant plants in the 2017 population of Kochia plants is greater than the proportion of resistant plants in 2014 population of Kochia plants. All right, so they have made their conclusion based on the original context. They said, hey, p-value is less than alpha, right? We could additionally state that we reject the null hypothesis, and we have evidence for the alternative, and then make that second part of the statement. They said basically saying what evidence for the alternative means in context. It's not necessary that you say you reject the null hypothesis, but you should say what you have evidence for in context. Right? So now grading. How do they evaluate these things? Right? Each section, section 1, section 2, section 3, receives a grade. Based on how those all get graded, you get a number of points for the question. Right? This section would be considered essentially correct if the response satisfies components 1 and 4 and at least one of the remaining components. So that means 1 and 4 have to be there in order to be considered to be essentially correct. Right? Component 1 is that the hypotheses imply equality of proportions in the null hypothesis and correct direction in the alternative hypothesis, which utilize an appropriate population parameter in words or symbols. So again, they allow, you don't necessarily need the variables if you don't want to use them. You can just use words. Right? The fourth component, which is also required to be considered essentially correct, is that the two sample z-test for proportions is identified by name or formula. The other two components would be that you identify parameters that are population proportions, or that both parameters are correctly defined as proportions of resistant plants from 2014 and 2017. Right, this would be considered partially correct if the response does not meet the requirements for E, but at least two of the components are satisfied. Right, so you're partially correct if you get half the components there. Incorrect if there are less than 2 components. For section 2, right, which is checking conditions and doing the calculation, is essentially correct if the response satisfies components 1 and 2, so those have to be there, and at least 2 of the remaining components. The first 2 components here notes that the use of random samples in 2014 and 2017 satisfies the randomness condition. Checks for approximate normality of the test statistic by showing that the expected numbers of resistant and non-resistant Kochia plants are both larger than some commonly accepted criterion. For example, some textbooks use 5, ours uses 10, that's what we're used to using for a large counts condition, right? We use 5 for large counts when conducting a chi-square test. Right. So those 2 things have to be there, and then 2 out of these 3 We have notes that the population of plants must be extremely large in both years, thus satisfies the independence condition. Reports a correct value of the z-statistic. Reports a p-value that is consistent with the stated alternative hypothesis and reported test statistic. So consider this. You can be essentially correct and have the wrong p-value. Okay, so if you make a mistake and you find the p-value for less than and not greater than, but you have these other 4 things, you could still be given most credit for this section. Partially correct if the response does not meet the criteria for E, but at least 2 of the 5 components are satisfied. Incorrect if the response does not meet the criteria for E or P. The last section here, the conclusion, is essentially correct if the response includes the following 3 components. So you have to have all 3 of these things to be considered correct on your conclusion. Provides justification of the conclusion based on a correct comparison between a stated p-value and an alpha value of 0.05. So you must compare those 2 things and say the p-value is greater than and the p-value is less than the alpha. Right. Provides a correct conclusion consistent with the alternative hypothesis. Right, so in this case, being correct is correctly seeing that the alternative hypothesis has evidence for this particular problem. The conclusion is stated in context. Can't forget the context. Right, you will be partially correct if the response satisfies components 1 and 2. Right, so if you have 1 and 2 and you forget the context, you're partially correct. Right, if the response satisfies components 2 and 3, you have a correct conclusion consistent with the alternative, and the conclusion is stated in context, but you forgot to say that the p-value is related to alpha. Right? Or if the response satisfies components 1 and 3, right, you have the comparison between p-value and alpha, and the conclusion is stated in context. And based on the p-value from section 2, so considering you may have gotten the wrong p-value, either the conclusion correctly rejects the null hypothesis but does not state that there is convincing evidence for the alternative hypothesis, or the conclusion correctly fails to reject the null hypothesis but does not state that there is not convincing evidence for the alternative hypothesis. So they're accounting for calculating errors, like maybe you got the right test statistic but your p-value is incorrect because you made some error in that, so that throws off your conclusion in some way. This accounts for that. You can still be partially correct with that error. If you have only one of these things there, it's going to be marked incorrect. And that is a sample solution to that problem along with the scoring guidelines. Is there any questions? Is there anything I can clarify? Okay. Are there any other general questions having to do with the AP exam that you would like answered or addressed? All right, so that is all that I have for you guys today. I don't want to go over any more than that unless there's things that you absolutely or that you would like me to review. That is what I have prepared. Use this time now to study on your own, review things. If you have any questions that come up between now and the test, please send me a message so I can help you with that and give you some guidance. I do have a 4th period class that is not AP Stats, so after 10:45 I won't be very available because I will be in that class and teaching that class. But if anything does come up, I'll do my best to respond if I can. Other than that, our last class is tomorrow. It'll be very brief. I'll be honest. It's not going to be much. It's just going to be kind of a check-in and see if anyone has any questions. You know, see if anyone needs help to make sure that their grade is what they want, and that'll be about it. It's going to be super short because there's really nothing else for me to teach. Right? The AP exam is today. So with that, I wish you good luck if you're taking the exam. You know, hopefully it goes well. And, you know, you've done all that you can to prepare. You should hopefully feel good about it. And, you know, it'll go good. It'll be good. You'll all do great. So have a great rest of your day. And we'll see you all tomorrow.